College Algebra, Chapter 2, Section 3, Lines. There are 10 objectives, but they go pretty quickly because it all deals with lines. Linear equations. Now, the first objective deals with slope. Because every line has a slope. They want us to calculate and interpret slope. Okay, so there's a bunch of ways of doing slopes. For whatever reason, they used m for the slope. You can do the rise over the run. It's the change in y over the change in x. This you'll use later in calculus. It's y sub 2 minus y sub 1, so y, over x sub 2 minus x sub 1. The order doesn't matter. If you want to do y1 first, you better do x1 first, or you get something wrong there. A sign change, at least. And if you've taken trig, or will take trig, it's the tangent of the angle phi, which is the angle between the positive x-axis and the line itself. That's what phi is. Okay. But all that stuff can be useful. Rise over run is useful when you've got graphs. This delta, change in y over change in x, can help us when we're interpreting the slope. And the calculated, usually though, we have 2 points and we find the difference in the y's and the difference in the x's. So, in order to interpret, and we're going to do some examples later, but right now get all these formulas set up. This is what we'll say, for every unit change in x, that's that delta x stuff, there will be a change in y. That's that delta y. The delta is used for change. In fact, delta x really means x sub 2 minus x sub 1. And delta y really means that. And that's sort of how we'll mention all this. We'll need to know about the units, feet or miles or all kinds of different units that we could be using. But we'll talk about that change in x, the denominator, for every unit change. So when x changes by 1, how much does y change? That's really the interpretation of the slope. So, next objective. Objective 2. What is the sort of generic equation for a vertical line? Well, a vertical line, if you think of the graph, the only time it hits the y-axis is if it is the y-axis. Otherwise, it's just a line through some particular value of x. Could be 0. But that means that x is always the same, but y is a thing that changes. All of these points, if this is x sub 1, then that is always the same, and y can be a bunch of things, anything. Any real number. The way to write that is just saying, I don't care about y, give me any y. Whatever y is, x will equal, we'll call this a, I guess. This a right here. Does that make sense? So, vertical line is just x equals something. Objective 3. Well, that is 3. I'm sorry, this was 3. You probably noticed that. I didn't. Let's go back to objective 2. Next page. see, a graph given a point and a slope. Okay, suppose you're given a point. Just pick one. How about 1, 2? Suppose you're given a slope. Pick one, 2/3. How do you graph it? Well, you plot the point. One, 2. And from that point, you use your slope. This is the rise over the run. Up 2 over 3. So someplace over here is another point. Now, whatever reduces to 2/3 is going to work. You could go down 2, that's a -2, and to the left 3. And that point will also be on that line. You could go down 4 and to the left 6. That point will be on the line. Anything that reduces to 2/3 will be a point on this line. That's what objective 2 was. How do you draw the graph given a point and the slope? We've done objective 3, vertical line. What is that again? Refresher, real quick, quiz. X equals sum A, vertical line. Objective 4. The point-slope form and horizontal lines. Okay, first of all, we're going to do the horizontal lines. Horizontal lines, like vertical lines, are easy to figure out because vertical lines, it's x equals something. Horizontal lines, it's y equals something. And of course, we can call this B because we usually reserve B for the Y-intercept. I guess we can use A as the X-intercept. And B is the Y-intercept. So any horizontal line is y equals some b. B, some number. It's always going to be the same. X can be anything you'd like, but y is that constant b. The point-slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. What is the point? The point is x sub 1, y sub 1. The slope is m. So if we're given the point, x sub 1, y sub 1, and if we're given the slope, we can find the equation because the only thing left is the x variable and the y variable, which is what we need. So it's almost too easy if you have to write it in point-slope form. If we're given this point and slope up here, it's y minus, well, y sub 1 is 2, equals m, which is 2/3, times the quantity x minus 1. Now, if this were 1 negative 2, then it would be y minus a negative 2, or y plus 2. So be a little careful. In the form, this subtraction is necessary. It will change when you have negative values for x or y in that point. Objective 5. Find the equation given 2 points. Let's do a next page here. Objective 5. Find equation given 2 points. Well, the only form we have right now is that point-slope form, but that makes things for good. Suppose you have the point 1, 2, and another point, say a negative 3, 4. If we're given 2 points, we can find the slope. It's y sub 2, 4, minus y sub 1, 2, over x sub 2, negative 3, minus x sub 1, 1. So the numerator is 2, the denominator is a negative 4, our slope is a negative 1/2. And we can pick either of these 2 points for our point-slope form. I'm going to choose this first one. Y minus 2 equals slope negative 1/2, x minus 1. By the way, that's exactly the same if you would multiply things out and collect stuff as y minus 4 equals a negative 1/2 x plus 3. Objective 6. This is the one you probably know. The slope-intercept form. Well, this is really the point-slope form with a special point. It's the Y-intercept. And the Y-intercept has always got 0 for the x. So that's a special point for the point-slope form. And if you wanted to, I guess you could figure that out by saying, okay, let's suppose our point is 0, because this is the Y-intercept, and b. And the slope is, of course, m. So it's y minus b equals m x minus 0. Or y minus b equals mx. Well, let's put that b on the other side. Add b to both sides. Y equals mx plus b. That is the point-slope form. If we would put one or both of these equations up above here in point-slope form, they would look exactly alike. So let me see if I can squeeze that in. So if we move this one, let's move it down here. We're going to have to write it pretty small. So I'm going to distribute this negative 1/2. So I get y minus 2. It's a negative 1/2 x plus 1/2. Right? Distributing this. So I'm going to add 2 to both sides. I get y equals a negative 1/2 x. And adding 2 to this is 2 1/2. Let's write it as an improper fraction. 2 1/2 is 5/2. Okay. Let's do the same thing here. So it's y minus 4 equals, let's distribute the negative 1/2. Negative 1/2 x minus 3/2. Now, I'm going to add 4 to both sides, but not really 4. I'm going to add 8/2 to both sides. Same as 4. So it's y equals a negative 1/2 x. Positive 8/2, negative 3/2 is a positive 5/2. Oh, look, they're the same. Doesn't matter which point you use on the line, the point-slope form will give you the right equation. You just maybe have to finagle it a little bit. Okay, now that we've changed colors. Objective 7. Given an equation, find the slope and the y-intercept. We should say a linear equation, I guess. Find the slope and y-intercept. Well, all you really have to do is put it in slope-intercept form. So, what we did before, if we have, say, 3x minus 5y equals 7. By the way, this is going to be called standard form, but that'll be later. Let's put this in slope-intercept form. That really means solve for y. Subtract 3x from both sides. Negative 5y is equal to, I'm going to put the negative 3x first, plus 7, because that's the form, right? Divide everybody by a negative 5, and you get y equals positive 3/5 x minus 7/5. What is the slope? 3/5. What is the y-intercept? Negative 7/5. So, slope 3/5. B, the y-intercept, negative 7/5. Not so bad. Solve for y. Objective 8. Graph ax plus by equals c, standard form. They don't mention that here, I guess. Well, we should. Graph ax plus by equals c. This is called standard form. Now, what we have to also remember here, just to make sure, a, b, and c are all integers, elements of the integers, and a should be greater than 0, positive. I guess it could be equal to 0, but it's greater than 0 for this form. How do you graph this ax plus by equals c? Well, let's go back up to this one and see if we can graph this. Now, you know how to graph that, I believe, using the slope-intercept form. You plot the y-intercept, the negative 7/5, and you use the slope up 3 and to the right 5, or down 3 and to the left 5 to find another point and connect the 2 points. If you wanted to graph this without doing all that change, you can find, perhaps, this doesn't always work, because the y and the x-intercept is what I'm going to use, but sometimes both the x and the y-intercept are 0, and then it's not very useful. That gives you 1 point. You need at least 2. The y-intercept is when x is 0. So we just have a negative 5y equals 7, or y equals a negative 7/5. Well, we knew that from over here, but I didn't know that if I had started here. So y is a negative 7/5. That's negative 1 2/5. That's someplace right here. The x-intercept is when y is 0. So 3x equals 7. Or x equals 7/3. So the the x-intercept is 2 1/3. That's someplace right here. Once you've got 2 points, you can graph the line. So you can use standard form to draw a graph. If it's not the same point 0, 0, then you can use the x and y intercepts. You can use the slope-intercept form to draw a graph. Plug it into a negative 7/5. Go up 3. I'm going to go up 3/2, and to the right 5/2, and you'll find another point. You can do the point-slope form, any point on here, and the slope up 3 and to the right 5, down 3 to the left 5. So all of this stuff is going to work nicely. Objective 9. Parallel lines. What do we need to remember? If m sub 1 is the slope of one line and m sub 2 is the slope of another line, if they're parallel, then the slopes are equal. It's that simple. Objective 10, perpendicular lines. Well, not as nice. If they're perpendicular, they're not the same. And they're not just opposites like one's positive, one's negative. They're opposite reciprocal. Take the opposite sign, flip it over, and you got the slope of a perpendicular line. So for this one, of course, y equals 2x plus 5, you can have a different y-intercept, like a negative 5. But for this to be a parallel line, it's got to have that 2x there. For this one, you'd have y equals 2x plus 5. You can even, in this case, cross at the same spot on the y-axis. But the slope has got to be the opposite and the reciprocal. So, you want to do some examples? Let's see. Now for some examples, I've already drawn these out because it takes a little time to draw it carefully. But we're looking at page 185, number 14 first. Here's the drawing you're given. You're supposed to find the slope and then interpret the slope. So, first of all, how are we going to find the slope for this? Well, to find the slope, we're going to take the 2 points, right? 2 minus 1, the change in y, over 2 minus a negative 1, the change in x. So this is 1 over 3. So the slope is 1/3. Interpret the slope. Okay. So you can say, as we did before in that last page, for every 3 units in change of x, y will increase by 1. Now, there are several ways of doing this. That's not the only way. You could say, because I talked about just 1 unit change, well, for every 1 unit change in x, y changes a third, because it takes 3 to change 1. Depends on how you want to look at that. But that's at least, if you write all that, 4 steps. Drawing the picture for the here. Number 44, we're supposed to find the equation of line L. That's this line here, the one that goes through this. Okay. If we know this is y equals negative x, then we know the slope of this line is, we'll call it m sub 1, is a negative 1. If we're told that L is perpendicular to that line, then the slope of line L is a positive 1, opposite sign reciprocal. And we know that this is the y-intercept at 0, 2, so b is equal to 2, and we can write y equals 1x plus 2. If you want to write in the slope, you don't have to, I guess. And that's the equation for line L. Now, if you're asked to write that in standard form, you've got to get x and y on the left in that order, x with a positive integer coefficient, and all the numbers on the right. So let's do that, just because I'll probably ask you to do that on the test. So if you subtract x from both sides, you get a negative x plus y equals 2. Almost what I want, but a, that leading coefficient, I want positive. So change everybody's sign. X minus y equals a negative 2. Now you've got it in standard form, slope-intercept form. We could write it in point-slope form if we needed to. Any form you'd like. Most of these problems are finding equations of lines. If you look on page 186, The way to do this is usually to find a point and a slope. If you can find a point and the slope, then the point-slope form will work for you. If you've got a special point, like the y-intercept, then certainly the slope-intercept form will work for you. If you know 2 points, then you can find the slope, and then you've got a point. All of that stuff works. I'm going to just pick one of these, just so you have one more to look at. Number 60. Oops. And now I've just messed this thing up. Just a second. Just a second. Okay, let me try this again. Number 60. I want to find the equation of a line parallel to y equals negative 3x containing the point negative 1, 2. So where do we start? Well, if I want to parallel this slope, call it m sub 1, it's a negative 3 over 1, right? It is a fraction, it may be helpful. So parallel lines, it should be the same. Negative 3 over 1. Okay. If this were perpendicular, that 1 in the denominator might be very useful. The point that we're given is negative 1, 2. We're going to use it in the point-slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. And you might say, why are you writing all that stuff down? This is going to help me when I come back and look at this and say, that's the question. I want to find the equation. Maybe I should put that on there too. Find equation. Parallel to y equals and containing. There's a slope. There's the slope I need since it's parallel. The point-slope form because I've got a point in the slope. So y minus 2 equals, the slope is negative 3, x minus, so I'm going to put plus 1. And then I'm going to write it in every single form just in case on the test they tell me to write it in a different form. This is one answer, possibly. If they say write it in any form you want. Boy, is that a straight line. But if I want it in, this is point slope. If I want it in slope-intercept on the test, then let's see. So I'm going to distribute that negative 3 first. Negative 3x minus 3. Then I'm going to add 2 to both sides. Negative 3x minus 1. So that would be my slope-intercept form. And standard form, let's see, I need the x's over here on the left too. 3x, oh, that's nice. Plus y equals a negative 1. I don't have to do anything else because I've got integers for the coefficients and a, that leading coefficient, is positive. I got any form you want, dude. So you can do the rest of these.